In this video, we're going to continue working our way through the Agisoft Metashape process for creating a 3D model from your photographs. In the last video, we aligned our cameras and created our sparse cloud. We also rotated our object to 3D space, matched the bounding box of that 3D space, and then also shrank down our region to limit the area for which Metashape is going to expend resources to process the data. We're now going to go ahead and we are going to create our 3D model, our mesh, and we're going to do it in this case by using the build mesh from depth maps option. In the case of our models, and this time we're going to choose that we want to create medium quality depth maps. This is a balance between speed and detail that we're looking for here by using the medium setting, and then ultimately from those medium quality depth maps we're going to ask it to create a high face count. Agisoft will go through and based on the results of the medium depth maps it will decide how many polygon faces it can create from that data. We're going to accept the defaults of interpolation being enabled, and at depth filtering we're going to set at mild, which is also the defaults, and we're going to allow it to calculate vertex colors once it has finished creating the mesh. When I go ahead and hit OK, you can see that Agisoft is going to start generating those depth maps. It's going to examine each of our photographs that's in the data set. In this case, it's 106 photographs that are 24 megapixels in size. It's going to use a reduced quality version of those photographs because we have chosen medium settings rather than ultra high. Ultra high uses the original camera resolution, which in this case is, I believe, 6,000 by 6,000 pixels. In this case, it has reduced that significantly to smaller images to allow the depth maps to be generated much more quickly. This can be a very intensive process. It will use a lot of the resources on your computer, including the resources of your graphics processing unit as well as your CPU, depending on what you have available in your specific setup of your computer. You can see that it's telling me we've got about 5 minutes in which it's going to take to create the depth maps. Once it has finished creating those depth maps, it will then use those depth maps to create the mesh itself. This can take a significant period of time. One thing to note is that if you are generating depth maps, depending on a setting that you have set in the preferences within Agisoft Metashape, it will or will not save those depth maps for later use. In my case, I have chosen to save the depth maps, which can be very, very resource intensive. They can take up large amounts of space in your hard drive, so it's not necessarily an option that you always want to choose. But because I know that I want to also create a dense point cloud for this model to demonstrate that process for you, by saving my depth maps, I can reuse those depth maps to generate the dense point cloud. So we're going to go ahead and we're going to let this process run itself through here and finish out creating the depth maps. I'm going to pause the video while it does that. And then we'll come back when it's finished. So we're just checking back in on the progress of our generating our mesh. And we can see now that it has finished creating our depth maps and is now working on generating the mesh from those depth maps. It took approximately 5.5 minutes to create the depth maps. It's now been processing the mesh from those depth maps for approximately 1 minute, and it's now 9% done. And it's telling us that it's going to be roughly 7 minutes left to create the mesh. As you can just see, it drastically dropped down from 7 minutes to now only down to 2.5 minutes left to create our mesh. It all has to do with how well it's able to match up those depth maps and create the three-dimensional points, and then from those three-dimensional points create the individual triangles or polyfaces of our model. Since this is going relatively fast, we're going to let it keep running as it does it live, so as you can see what's going on. As always, if you have your console pane locked on the right-hand side of your application, you can kind of see that it actually is working. It is doing stuff. It's not just stalled. We've got a little less than 2 minutes left. You can see it just jumped down now to almost 1.5 minutes. As the process goes on, many times it will actually start to drop and drop and drop again as it moves through that process. Looking at less than a minute left. Once it finishes generating our mesh, it's then going to go through and it's going to calculate what's called vertex colors. So for each corner of each triangle, it's going to calculate a color value to put with that so that we can see sort of a false coloration to our model that's finished. Occasionally it will jump back up a little bit as it's processing. So you can see here it's bouncing, it's going down to 15 seconds left, bouncing back up to 20 seconds left. And you'll see that happen a bit toward the end of the processing as it's thinking and doing the final calculations. You can now see that our mesh is finished. Now we're moving into the calculating vertex colors. Only have a bit of time left on that, and then it will finish, and then we'll have a false colored model. And when I say false colored, that's just referring to the fact that the colors are not as vivid and as crisp and as sharp as they would be when we create our final color texture to our model in the next step of this process. And now the process is finished. We now have a detailed 3D mesh that we can look at, a 3D model in its entirety. We can zoom in, and as you can see, the colors are not crisp and sharp. As I said, it's just because it's colorizing only the vertices on the object. The resulting model, as we look down here in our information, is telling us that we have 940,000, almost 941,000 individual triangular poly faces in our model. Up here on our toolbar, we can now look at the pyramidal icon here. If we do drop downs, there's lots of options. Here we're looking at our shaded model. This is the false colored model. We can use our solid model, which gives us just a bluish or grayish blue tint to the model. And as we can turn around here, I'm just rotating the model, making sure that my icon here, that I have the navigation icon clicked. I don't want to be over here in rotate object because that's going to rotate it in 3D space. Have just my navigation clicked. I can now turn it around. Look at the bottom. The bottom is not solid because obviously we do not have information on the bottom of the tombstone. That would be on the inside of the ground. But we can see that we have a lot of detail preserved on this model. I can switch to what's called wireframe mode, where we can see the individual triangles. And so you can see that in areas where there is more detail on the stone, like in the carving areas, the triangles are smaller and denser. And as we get into areas where the stone is much more just sort of flat and not a lot of detail to record and present, the triangles are much bigger and less dense across the model. So we now have a very good, very detailed model. And again, because we oriented it to top, bottom, front, left, right, we can hit the 7 key, look down on our tombstone from above. We can hit the 1 key, look in from the front. We switch back to our shaded view here. We can hit the 3 key and look from the right, or Control 3 and look from the left of the tombstone. It's not quite perfectly lined up. If we look at the stone here up at the top, you can see that it comes off at a little bit of an angle, but that's okay for right now. We can always fix that later on. To fix it, it's a simple process. We just rotate our object again. We hit 7 to make sure we're in top view. Click on the rotate object line. Zoom in here a little bit more now that we can see more of what we're looking at rather than just little spaces. Hold the left mouse button down, drag my mouse till it matches up. I can do the same thing for left and right. Again, we'll just match what should be a straight edge or a vertical line. Check our bottom line, looks great. Go over to our side view, and again we can see that it's pretty good match up there for being vertical, just slightly off. Bring it back in here, look at the top. But we now can see that our bounding box is off at an angle here. We look at our lines for our bounding box. Because we've rotated the object, it's not in the same as the bounding box. We can fix that very easily by just going up to the scripts that we have loaded in called UWL tools, hit the bounding box, the coordinate system, and that will just rotate the bounding box. It doesn't change the fact that we recreated the model missing without it being perfectly aligned. But the main part of the model is now aligned. And we can fix that later too, so that we either reconstruct that again or we trim our object to its bounding box. We resize the bounding box and then trim the model by that, and that's in a future video. But we now have our 3D model. And again, this was creating it directly from Build Mesh using depth maps. So it skipped the stage of creating a dense point cloud. If we want to create that dense point cloud, we can do that. As I said in my preferences, I have told Metashape to save my depth maps. So my depth maps are still available here, because to create a dense point cloud, the first step would be for the software to create a depth maps. Our depth maps, we can go ahead and reuse them in the process. I'm going to first go ahead though and save my model, and I'm going to do the dense cloud as a separate video, and then we'll create our mesh from the dense cloud in that separate video. Right now we could continue on and we could go ahead and create our texture. So we're going to go ahead and do that as part of this video, and then we'll create in another video, we'll create a model from, we'll create our dense cloud and then create the mesh from the dense cloud, and then we'll texture that one, and we can compare the two. So I'm going to go up here to workflow. I'm going to say build texture. I want to create a diffuse map, which is typically the default. I want to do it from the original image sources. I'm going to use generic mapping mode, which is how it's going to map the colors onto the model. I'm going to use mosaic blending mode, which is the default. And I'm going to do a very high resolution, which is 8,192 pixels by 8,192 pixels. This is what's typically referred to in the 3D industry as an 8K texture. We could do a 4K, which is a little bit less resolution. It takes up much less size. It makes your model more navigable quickly on low resource machines like cell phones. So why don't we go ahead and we're going to do a 4096 model in this case. For advanced, we're going to click the arrow to show that, and we're going to say enable hole filling. So in case there were some holes in our model, it would extrapolate over top of those, and we're going to enable ghosting filter, which will filter out information from the textures if we had some surrounding geometry that was in there that we didn't want to include. So I'm going to go ahead and hit OK, and we're going to let this model process. The first thing it does is it parameterizes the mesh. It basically figures out how best to put color on those poly faces. That can take anywhere from a few seconds to many minutes to a half hour, depending on the complexity of your model and how many poly faces you have, how much data it has to work with. So we're going to go ahead, we'll pause the video recording, and we'll let it process that, and then we'll come back when it has finished. So the software finished parameterizing our mesh. It's now building the textures. This can be a very fairly quick process depending on your processing capabilities of your computer. And what it's doing is taking those 104, 106 images, and it's trying to find the best parts of each image and wrap it onto the model into the best locations. So now we're still looking at our model in shaded mode here. We can now go and tell it we want to look at our model in textured mode. So now we're looking at a very detailed, very high resolution version of our coloration of our model, which is derived directly from the images. We can now turn the model around, look at it in full color, and we now have a complete model. This model can then be exported out to other software depending on what your final purpose that you want to use it for. We can also notice that I did something that oftentimes happens. I forgot to change out of the rotation of object mode, and so I have now actually rotated my object in three-dimensional space, which was not what I wanted to do. I wanted to just rotate the model around. It's a very common problem. So in order to fix that, I would need to go back to my top view, click on rotate object, remove my model again so that it all matches up. Front view, side view, top view again. And then once I have it where I'm pretty happy with being back in alignment, now I can go ahead and just click bounding box of coordinate system again, and now make sure that I click on my navigate icon before I rotate my model. I actually purposely did that because it's something that very commonly happens if you've been rotating your object in space, in three-dimensional space, and orienting the bounding box. You oftentimes forget to switch back over to just pure navigation cursor. So there's our model. In the next video sequence, we're going to talk about adding dimensionality to our model. As you can see in our photographs here, there were scales with targets placed in the original photography. We can use those targets and those scales to ensure that our model is scaled to real-world coordinates if we're using Metashape Professional version, which allows the ability to scale your models. If you don't have the professional version, you can always scale your model using other software. You can export your model out, bring it into something like Blender 3D, and if you know that your tombstone from here to here was 1 meter, you can then measure that in the 3D graphics software, figure out what it is, figure out what the scale factor would be to convert it to 1 meter, and then just change the dimensions of the object in the 3D software. But we're going to go ahead and we're going to do that in Metashape in a future video.